If you understand web applications, you know that they have two sides: backend, which runs on a server or set of servers, and a frontend that runs on your browser. Now, even if the web application runs on a cluster of servers, they are controlled by a single entity. The problem is, if the centralized server crashes or gets disconnected from the internet, the web application would stop working. The centralized nature of these applications make them vulnerable to security threats and censorship. Now replace the backend with a smart contract that runs on a blockchain network. As blockchains are distributed networks, all the valid nodes of the blockchain have copies of data of the smart contract, that is, the backend of the dApp. A smart contract cannot be deleted unless it is programmed to do so. So it is practically impossible to randomly modify or censor the backend of a dApp, which is a smart contract running on a blockchain network. Further, the frontend of the dApp can be hosted on a decentralized file system such as IPFS or interplanetary file system. Having the backend on a distributed database also makes it possible for dApps to have zero downtime. Centralized applications need to be disconnected from time to time for maintenance or to deal with security threats. As dApp backends, that is, smart contracts, are served from many nodes, they do not need any downtime. The application still runs if one or more nodes go offline. dApps offer various benefits such as privacy, data integrity, trustless computation, apart from resistance to censorship. dApps also have some limitations such as lack of maintainability, high performance overhead, and difficulty in building user experience comparable to centralized systems.